Well, welcome to Earth Science. He's excited. It's time for the density lab. So what we're going to do, you're going to probably have to pause the video a couple times or rewind it, but what we're going to do is work our way through the basic densities of these things through a couple of different methods. I'll try to do this on my phone the best I can. No promises. We'll see how it goes. All right, so object one. What we're going to do is a length, width, and height. So I'm looking at, should I tell you? What do you think? About 7.7? About 2.5? Sorry, this is going to be a little clunky at times. Take our science next year. We want to do this. Maybe 0.6. All right, so those should go in your lab, and again, rewind it if you get stuck in any of those. So that's length, width, and height. How do you get the volume? And then how about the mass? There you go. Oh, what's it going to be? There's your mass for object number one. Object number two. Some of these are cubes, and some of them are off by the tiniest bit. I'm thinking about 1.3. See there, you might go about, yeah, that's probably 1.3 again. And then the other dimension would be this one. And what do you know, it is, maybe we're gonna go 1.2 on that. What do you think, 1.2? So there's your length, width, and height for that one. And our mass for object number two. All right, now we're going to move into these cylinders. Now the trick with these, there's not a formula for the volume of a cylinder. There is, but we're going to do the displacement method, which maybe we know, where you chuck some water in there. It doesn't really matter how much. Let's see what I got. Looks like I'm going to give it one more drip there, get it off the line. So if you remember this meniscus deal, you want to see right at the bottom of that meniscus. And then, oh, I dumped out more than I wanted to. This is going well. Hey, that looks pretty good. So we've got, with this one, 40. The other side is if you're counting down. We don't want to do that. We want to count up. So we got 40 milliliters. I'm going to tip this so I don't break it. Drop it in there. And it looks like we went up to about 46. All right, let me put the mass. The smarter science teacher might have done the mass before he dumped it in water, but you guys are stuck with me. Price you pay. There you go. There's your mass for object number three. Now I will be smarter this time. Object number four, let's do the mass first while it's dry. Sorry for the reflection there. 17.9. Whoop. Up. What are you gonna write down? There's our mass. Looking good. I'm liking it at right about 45. Drop it in. Not splash. And it looks like we went up to about 51. So if I went from 45 to 51, how much? Once again, that was number four. Number five, which is wet because I've made a mess of the station, but I'll dry it off. There we are. Mass for number five. Get some water. 45 again. And we're at 51 again, which makes sense. I mean, these are built to all be the same, so that'll be that. So that should get us 1, 2, 3, 4, 5. 6 and 7 I'm going to be a little bit tricky with. If you know how to do density equations, which if you made it through the day before we got to this lab, you do, how can that be tricky? So here's what I'm going to do for number 6. I'm going to give you the density. The density is 5.1 grams per milliliter. That's what my messy writing says right there, 5.1 grams per milliliter. And then I'm going to give you the mass, and you're going to have to try to tell me the volume. You know what I'll do too? I'll figure it out after the video's over, and then we'll see how close you got. All right, so there's your volume. I'm sorry, there's your mass. You're going to figure out what the volume of that rock would be, what that mineral would be. This is a mineral called pyrite or fool's gold. And since the rules are that, you know, all of the same objects have the same density, which you're going to have to figure out up here once you do your numbers, we know that all the pieces of pyrite in the world have that density. So at that mass, what would the volume be? And then we'll see if you're right. And then we'll do this one the opposite. This is galena. It has a density of 7.6 grams per milliliter. And we'll do the displacement test on this, see if it fits in there. Are you going to fit in there? No, you're not. So we're going to the big one. I'd be happier if it fit in there. All right, this one goes by 5, so I'm slightly worried we're not going to get enough of a difference here. Let's see if I have a bigger one. Thanks for sticking with me. You know, y'all have a choice. All right, fits in this one. This will be good. Let's try it again. All right. So I'm thinking we're at, what do you think, 50, I'll go 52 on that. Drop it in. And we went to, what do you think? Why did I not say anything? You tell me what you think. Then you can figure out the volume. 7.6 is the density. Then you tell me what the answer is going to be. What is the mass when I dry it off and drop it on that scale? All right, that's going to do it for the density of solids lab. Thanks for sticking with me. You got your paperwork? Good luck. Matt Mardigan says, so long for now.